Hello everyone, welcome to Eduxcite classes. My name is Monit and in today's session we are starting with the A.2 forces and momentum. Those students who have not watched my A.1 kinematic series, I will request you to please go through the complete playlist. The link is given in the description. Okay, and in this video we will talk about 2.1, that are the types of forces, free body diagram and the equilibrium questions. Okay, so please share this video as much as you can with your friends and the classmates. That's the only purpose of making these videos, so it reaches to the masses. And in any of the question, if you have any doubt, just you can comment below or you can scan the QR code, or for any tutorial sessions please leave a message on my WhatsApp. Okay, so without wasting time, let us start with the very first question. Also, you can download the PDF of this video and the marking scheme. The link is given in the description on my website. You can download the PDF. Okay, so let us start with the very first question. And before that, you should just go through it, train your mind for all the different types of forces. I'm not going into detail of the conceptual analysis of the different types of forces, but just have a quick read of this before moving on to the questions. You can find the PDF, so I'm skipping the part. So let us start. Pause the video and solve question number 1. Okay, now in this question number 1, if you see, first of all, draw the free body diagram. This is one of the most, the basic part of topic 2.A.2 forces. So you can see here, we will assume these all things as a point object and we will draw the forces acting. So whenever you got a question related to the inclined part, try to draw along the inclination plane only. So the horizontal will be this and the vertical will be perpendicular to the inclined plane. So if I want to draw the free body diagram of the cart, I will assume the cart as a point mass. The weight is actually acting in the downward direction, so I will write W. You can mention W is the weight of cart. Okay, and then the normal reaction force will be perpendicular to the surface, so that can be written as N. N is nothing but the normal reaction force acting because it is in contact with the surface. It always, the normal reaction force always act perpendicular with the surface, irrespective of how the object is placed. It is always, if it is in contact, the object is in contact with the surface, it will always be perpendicular with the surface, 90 degree with the surface. Okay, now the thread is being tied, so there will be a tension in this direction. So T stands for tension. So this is how you can mention the free body diagram of the cart, which is placed on an inclined plane tied with a thread. Now using this, it is mentioned that the cart is in equilibrium. Now this term equilibrium is very important. The equilibrium just here in the forces represent that the net force acting on the object that we have considered is 0. That means that the horizontal and the vertical component of the forces are balanced. Okay, so using this we can find out the magnitude. This was the A part. So B, first part, I can find out the normal force. Now if you look at this particular diagram, whenever you got an inclined plane, now this is my inclination plane and this is making an angle theta. Don't do it in the free body diagram, I am just doing it, or let me copy this. Okay, so I have the same. Now what I will do is, I will draw the free body diagram. On free body diagram, I will draw the component. Like for example, if this is theta, so this will be, this is very common guys, you should know this angle will also be theta. How? Just pay attention. This is theta, this is 90 degree, this is 90 minus theta. Now if this is 90 minus theta and this whole angle with this is 90, so if this is 90 minus theta, then this will be theta. Okay, now if this is W, this is theta, so the component along the theta will be W cos theta and this will be and along the slope it will be W sine theta, right? Now if you got this, then you can easily solve for the normal force. So I can say the normal force is equals to, because it is in equilibrium, so the forces, I can say the Newton will be equal to, normal reaction force will be equals to W cos of theta, and weight will be equals to m into g, everybody knows that. So the normal force will be 0.8 into 9.8 into cos of 20. I have already done the calculation, so the answer comes out to be something near around 7.4 Newton. So the answer for the B first part is 7.4 Newton. Similarly, along the plane, if it is in equilibrium, so W sine theta will be equals to T. So you can say W sine theta is equals to the tension. Therefore, tension is 0.8 times 9.8 into sine of 20. So the tension comes out to be, I have already done the calculation, you can do as well, 2.7 Newton. So this is the answer for the B second part. So always remember, you have to resolve this type of inclination problems are quite common from your examination point of view. Always remember, the weight will always be vertically downward. If this angle will be theta, so the normal force will be balanced by W cos theta or mg cos theta, and the force weight component along down the plane will be mg sin theta. This you can remember always. Okay, so I hope it is quite clear. Now pause the video for question number 2. Okay, now always remember, in these type of question, when you are supposed to find out the tension T1, T2 and T3, and it is given that it is being tied and it is in a state of equilibrium, again the forces are supposed to be balanced. So first of all, you have to draw the free body diagram for the given object and make out the equations using the component of the forces. So how I'll do is, for example, so there will be two free body diagram, one of the threads, or you can say the cables. So this will be T1, this will be T2, and this will be T3, right? So this is tension T1. Tension is always away from the point T3, and for the traffic light I can say the weight is acting in the downward direction, and that is equals to T3. So from here I can say T3 is equals to W, which is equals to 100 Newton given in the question. Okay, now I will resolve this. Now this will be 37, this will be 53. So I can redraw this diagram as in terms of horizontal and vertical. Just check. So this will be T1 cos of 37, and this will be T1 sine of 37, because this is making an angle theta. So this will be the cos component and this will be the sine component. Similarly, here it will be T2 cos of 53, and this will be in the same direction, so they will get added up, T2 sine 53, and here it will be T3. Now it is given in the question itself that this is an equilibrium, right? This is an equilibrium. So I can say what equation I can make for, if it is in equilibrium, for equilibrium, the sum of forces in x direction is equals to 0, and the sum of forces in y direction, that is horizontal and vertical, is 0. So considering that, I can write down the equation as T1 sine of 37 plus T2 sine of 53 is equals to T3. This is the vertical equation in vertical direction, and in horizontal I can say it will be T1 cos of 37 will be equals to T2 cos of 53. Now using this I can say T1 is equals to T2 times of cos of 53 over cos of 37. Now using this relation, and this is, let us say, equation 1, and T3 is already 100, that is we know from above. This is equation 2. So what I can place is, and this will be, I have done the calculation, so it comes out to be something around 0. T2 times 0.753554, something around like this. You can use your calculator, guys. So I will place this value of T1 as T2 times this in the first equation. So using equation 1, I can say T2 gets common, so 0.753554 times sine of 37 plus sine of 53 is equals to 100, because T3 is equals to 100. Now using this you will get, you can solve the equation, you will get nearly around T2 as 80 Newton. So that will be the answer for tension developed in the cable 2. And if you put T2 in this equation, you will get T1 nearly around 60 Newton, and T3 we have already calculated, which is equals to the weight of the traffic light. So this is how we find out the tension T1, T2 and T3. I hope it is quite clear. This is one of the most simplest way to solve the questions when the forces are balanced or when the system is in equilibrium. You just have to resolve the forces into horizontal and vertical, make out the equation, substitute the unknown variables, and then solve for the values. Okay, I hope it is quite easy. If you have not understood, you can just comment below. I will try my level best to get back to you. Even you can download the PDF as well. Now solve question number 3. Pause the video and solve. Okay, now for the A part, we have to draw the free body diagram of object A. Now if you look at object A, just look at how it has been connected. So object A will have its own mass, and the mass of object A is capital M. So if I consider the object A as a point mass, so the M into G I can write like this. This is the weight of object A. There is a tension above, so I can draw a tension T A, or let us say T1. This is T1 and this is having a tension T2, let us say. So tension T1 is the first thread and tension T2 is the tension in the second thread, which is connecting object A and B. Okay, we have to draw the free body diagram for object A. So this will be mg, and this is, there is one more tension. Now tension is always away from the object. When I say away from the object, means the arrow should always go away when you are considering object A. Now if I want to draw the tension for object B, it will be away from object B. The tension will remain same, but the direction will change as per the object that you have considered. So for object A, the tension will be downward. Tension T2, let us say I draw like this, it will be like this. So this will be the free body diagram for object A. Now if I want to draw the for object B, although it has not asked, so it will be 2mg, this is for A and this is for B. 2m because mass is 2mg, and tension T2 I will draw in the upward direction like this. Okay, now the B part. Now B part is what? Calculate in terms of m the tension developed in object in each thread T1 and T2. So if I use this free body diagram, I can make out the equation because they are in equilibrium, they are not moving. So T1 will be equals to mg plus T2, and T2 will be equals to 2 times of capital M into G. So I replace T2 as 2mg. So T1 is equals to mg plus 2mg. So T1 is equals to 3mg and T2 is equals to 2mg. I hope it is quite clear, easy one. Now pause the video for question number 4 and solve. Okay. Now if you look in this question, these type of question are quite important for this particular session. The reason being, this has been added for the very first time. The equation of the forces of the buoyant force and the drag force has been added for the very first time in this syllabus. Okay, so I think the questions might come from these types of forces as well. Now how to solve this question? Look at how we will find out the mass of this buoy. So according to the upthrust force, or you can say if it is the object, if the object is floating, then we can say the buoyant force is being equal to the weight of the buoy. Okay, now we know the formula for the buoyant force, which is given rho of liquid V volume displaced times G, and that weight is equals to mass of the buoy times G. Okay, now if this is balanced, then we can say this G and this G gets cancelled. So in other term, I can say the mass of the buoy will be equals to density of the liquid is given to us, which is 1000, and the volume displaced is the volume which is being submerged in the water. So you can see this much volume is only submerged, so a cross sectional area is 0.2 and the height of the buoy which is submerged is 0.75. So if you do this calculation, you will get the mass of the buoy as how much? Yeah, I done the calculation. It is 150 kg. So that's the answer for the A part. Now the question is asking you, the buoy is now placed in a sea water of greater density than the fresh water. Explain the change, if any, in the submerged height of the buoy. Now if the density is greater, right, the mass of the buoy will not change. So if the mass of the buoy is not changed and the density will be higher, so 150 will be equals to, let us say, 1500 times 0.2 times x, right? So if this has increased, so this has to decrease, then only it will remain constant. If there is a x and y gets product, x into y, right? If x into y is a constant k, and if x is increasing, it means density is increasing, then y has to decrease in order to make the value constant, because the mass of the buoy will not change whether you change it in a different liquid or not. Okay, so mass will remain the same. So what I can say is the submerged height will decrease. So submerged height of the buoy will decrease when placed in sea water having density greater than the water. That is enough. Okay, I hope you have understood the question number 4. If you have any doubt, just comment below. Okay, now pause the question number 5. Okay, again the same type of question. Calculate the mass of the container. Now if you solve for part A, the mass of the container, I can say that the weight will be equal to the weight of the water displaced. The mass of the container will be equal to the weight of the water displaced according to the Archimedes principle. So the water is displaced of this much of volume, right, and the density of the water is given to you. So we can say the weight of container is equal to the weight of water displaced. This is nothing but the Archimedes principle. Okay, so weight of the container is mass of the container times G will be equals to weight of the water displaced. So weight of the water is density of water into volume that is displaced into G, right? So rho of water times volume displaced times G. So this G and this G gets cancelled. So mass is equals to 1 into 10 raised to power 3, which is the density of water, and the volume displaced will be 25 into 25 into 2, and these all are in centimeter. You have to convert this into meter, so into 10 raised to power minus 6. Okay, so if you solve for this, the mass will come out to be something near to 1.25 kg. So this will be the mass of the container. Now if you look at the part B, the part B says an iron bar of mass 4 kg is placed in the container. Predict whether the container will sink or not. So what we can say is, if we can calculate the maximum mass that can be sustained, and the maximum mass will be when the whole container is just leveling up the surface of the liquid, right? So if the whole height is submerged, then we can say the maximum mass allowed is equals to rho of water times complete volume of container. That will be the equal to the volume displaced. So 1 into 10 raised to power 3 times 25 times 25 times 10 into 10 raised to power minus 6. So if you do this calculation, you will get 6.25 kg. Now the allowed mass, the available mass is mass of the container plus 4 kg, 1.25 plus this, so 5.25. So you can say the allowed mass is greater than maximum mass allowed is greater than the available mass, therefore it will not sink. So this is how we can say. Okay, now try question number 6. Pause the video and solve. Okay, now in this type of problem, we know that if it is at a state of rest, the weight component is down the slope, and then the friction will apply in the upward direction of the slope. Reaction is always perpendicular, weight is vertically downward. Okay, now we have to determine whether the skis will slide down by themselves or not, and that will only be possible when the weight of down the slope, okay, is greater than the friction force, right? Then only it will be able to slide it down on its own, and the coefficient of static friction is given to you, and we know that the friction is equals to coefficient of friction times normal reaction force. So if I want to solve this, weight down the slope we have already discussed in the previous question will be mg sine of 1.7, right? And this should be equals to nu times normal reaction force, which will be mg cos of 1.7. Now mg and mg that gets cancelled, even though there is no information about the mass of the skis, because the reason being they are supposed to get cancelled out. So what we can say is sine of 1.7 over cos of 1.7 should be greater than nu, then only it will slide. Otherwise, if this value is less than nu, then this will not slide, and we know the value of nu. So once we find out the value of this, we can compare with the value given in the equation. If it is greater, then we will say it will slide down by themselves. If not, then we will say it will not slide down because the friction force is greater than the weight down the slope. So if you do this in the calculation, tan 1.7 is something equal to, I have already done the calculation, which is 0.02967. So we can say this is greater than nu. So we will say that nu is the given nu, the given static coefficient is 0.025, which is less than the above value. Therefore, the skis will slide down by themselves. Okay, so always remember, if tan theta gives you the value, if tan theta is greater than the coefficient of static friction, then the object will slide down on its own. If tan theta's value is less than the given coefficient of friction, then friction force will be greater. Therefore, it will not slide, it will remain in a state of rest. Okay. Okay, now solve the question number 7. Pause the video and solve. Okay, now first of all you have to draw the free body diagram. So if I want to draw, let us say this is a point mass object of book. Okay, so we know that what are the forces acting. One is the weight of the book, which is given already 12 Newton. Okay, then there will be a normal reaction force acting perpendicular to the surface. Let us name it as N. A force F is acting, let us say F, and a friction will be acting in the upward direction. Why friction is acting in the upward direction? Because the book is supposed to move in the downward direction, and friction always acts in the opposite direction. Okay, now the book is initially at rest. Calculate the minimum magnitude of F that is required so that the book does not slide down. So what we can do is, friction static coefficient is given to you. So what I can say is friction will be equals to 12 Newton and friction is equals to nu times N. And here I can say if the book is at rest, N is equals to F, right? So nu N is equals to 12, or nu times F is equals to 12. Now, if I want to find out the minimum magnitude, so for that the book has to just slide down. So I will use a static coefficient of friction. So F will be 12 over 0.75. So this gives me the answer for the A part, which is nothing but 16 Newton is the answer. Okay. Fine. Now for the B part, for the value of F, you have calculated in the part A, which is 16 Newton. Draw a scaled free body diagram for the book. So I think we have already done. Make sure that these arrows are all correct. Okay. So you can draw it here again. Yeah. So make sure these arrows are balanced so that it is in a state of rest. So friction will be balanced by the weight of the book and the force applied will be equals to the normal reaction force. Quite easy. Just remember that friction will act in the upward direction here. Okay, now solve question number 8. Pause the video and solve. Now the A part, explain how the ball reaches the terminal speed. Now these type of questions are quite common and we discussed the terminal speed in my previous video. If you have not watched, you can check the playlist, link is given in the description. Okay, where I have in a sequential manner I have started with the topic A. Now let me write down the answer first. Okay, so the buoyancy and the weight remain constant, but the drag force in the oil increases with the speed because the drag force is proportional to the speed. So at terminal velocity, the net force is 0. It means the weight of the object is equal to the buoyancy plus drag force, so that the ball is no longer accelerate and it moves with the same constant speed in the downward direction. And that is what do we mean by the terminal speed. Now for the B part, look at the data given. Make sure that you pay attention towards the units. Now the weight of the ball, now as I mentioned, the weight of the ball will be equals to the buoyant force plus the drag force. Okay, or here we can directly find it out. This is also fine, and the weight, if we have given the information, if you look at the values, we are knowing about the density of the steel and the radius of the steel. So the weight will be m times g, and m is density of steel into volume of steel times g, right? And density is equals to how much? 8000. Volume of steel is 4 by 3 pi r cube, which is 2 into 10 raised to power minus 3 cube. This will be the volume times 9.8. Now if you solve for this, you will get the weight of the ball. I have already done the calculation as 2.6 into 10 raised to power minus 3 Newton. So this will be your answer for the part B, first part. Okay. Then the buoyancy force acting on the ball in the oil. Now buoyancy force is what? Buoyancy force is, the buoyant force is rho liquid times volume of the displaced, and it is submerged, so the volume of the ball you can say times g. So density of the liquid is 920 times now if you calculate this, you will get the buoyant force as I have already done the calculation, 3 into 10 raised to power minus 4 Newton, right? And now determine the terminal speed of the ball in the oil. Assume the ball is affected by a viscous drag force. Now here we will use this equation, weight is equals to FB plus FD, and that FD is nothing but 6 pi neta r, V is the terminal speed. This formula is given in your data booklet, guys. So weight we have already done, so drag force will be how much? 2.6 into 10 raised to power minus 3 into 10 raised to power minus 4, and this will be equals to 6 pi neta r V, where neta is the viscosity of the liquid. So if you solve for this, will be the same. I am not doing the calculation here, you can do it in your calculator, and but just putting up the value for r in meters. Neta is already given. This is the value of the vegetable oil, which is the viscosity. By putting up all the value, we'll get the terminal speed as 0.73 meter per second. I'm not doing the calculation, you can use your GDC. Okay, so I hope this is quite clear for the question number 8. If you have any doubt, please let me know. Make sure you know how to use the formula for the drag force, and at terminal speed this condition will be there, because these are the two forces, drag force and the buoyant force, acting in the upward direction, and the weight is acting in the downward direction. So at terminal speed the forces will be balanced. Okay, now moving on to the MCQ, I have tried to collate few past year paper questions related to this topic which has already been asked in your IBDP exam, and few questions from other textbook. So just pause the video for question number 1 and solve. Yeah, so it's quite simple. If it is moving with a constant velocity means acceleration is 0, therefore the resultant force has to be 0. Option D is the right answer. Now try the question number 2. It is something related to your vectors, so I minimize it. You can try it now. Yeah, it is just a free body diagram. P is acting in the downward direction, L is acting in the drag force is acting in the left hand side, and this is the force being acted. A constant force is acting on the horse in this direction. Okay, now if you look at which one of the following best represent the free body diagram, this will be the free body diagram, right? So B is the right answer. Look at the arrows, this you have to remember. So the direction of the travel is this one, and this is how it has been. So best representation will be the option B. Okay, now pause the video for question number 3 and solve. Okay, yeah, so option for the which one will be the correct relationship? Yeah, so option C will be the right answer. W sine theta will be equals to the friction force. Now try for question number 4. Pause the video and solve. Okay, yeah, so if you can use the data, so friction will be acting in this direction, right? So I can say weight is, if I use tan, so it will be tan here, so that will be equals to the normal reaction. So friction will be 0.3 times tan, which is 3 Newton. So you can say friction, static friction is greater than the applied force, therefore the object will not move. If it was less than this, then we have used dynamic friction, then the object must have moved, and that too with, we have to see it will be what will be the acceleration, that we will discuss in the next video. Now pause the video for question number 5. Okay, now you can see that frictional force, as the value of your theta is slowly reduced, we can say the friction will be what? Friction will be equals to nu into n, right? And n is what? Nu is mg cos of theta. Now if theta is reduced, you can say if theta is decreasing, then the value of friction is increasing, right? So if the theta is slowly reduced, so friction force will decrease, and there will be no change in the static friction because it doesn't depends on anything else. So B will be the right answer. Now pause the video for question number 6. Yeah, so the explanation for this observation is, yes, we know that the maximum static friction are greater than the maximum dynamic friction, because once the object is moving, at a microscopic level the surface is not that much in contact with the stationary surface, therefore there will be less friction as it is moving, therefore dynamic friction is less than the static friction always. Okay, now in one go solve question number 7 and question number 8. Okay, if the point is in equilibrium, we can say the F1 and plus F2 will be equals to F3, and F3 is 6 Newton, so F1 plus F2 has to be 6 Newton, otherwise they won't be in a state of equilibrium. Okay, now question number 8, we know that if the graph of force versus extension length of a spring is given to you, then the graph denotes nothing but the spring constant. Now spring constant for this will be F2 minus F1 upon L2 minus L1. So that is option D is the right answer. Correct? Simple. Now this is a very well question. Just pause the video and solve. Okay, now what I can say is initially the weight, let us say mg is equals to k times L, right? And if the springs are connected in parallel, the coefficient of the friction will be, you can say the spring constant is inversely proportional to the length when it is connected in parallel. So if the length is halved, the spring constant becomes double, right? So sorry. So if the length becomes half, the spring constant becomes double. So this will become 2k and this will become 2k, and if they are connected in parallel, okay, then if they are connected in parallel, then the k dash will be 2k plus 2k, which will be 4k, right? So what will be the extension of the parallel system under the unchanged load? Now the load remains the same. So what I can say is mg will be equals to k dash times L dash, right? And k dash is now 4k equals to L dash is equals to mg. So here I can say k is equals to mg by L, right? So mg by 4k is equals to L dash. So or you can say L is equals to mg by k. So mg by k is equals to L. So this will be L by 4 is equals to L dash. So option A is the right answer. So always remember, when the springs are connected in parallel, the effective spring constant gets added up, and when it is in series, it will be the reciprocal of 1 by k1 plus 1 by k2 is equals to 1 upon k series combination spring constant. But here it will just get added up, so it is 4k and it is inversely proportional. So you can say if the length gets half, the spring constant becomes double. Okay, now this is for the series one. Pause the video and solve. Okay, now the new spring constant for Ks will be 1 upon k plus 1 upon 2k. So Ks becomes 2k by 3. So this is the effective spring constant of the combination. So option A and B are incorrect. Now we have to think in option C and D. Now extension of spring 1. Okay, so mg will be equals to k into ks into L, right? So I can say mg equals to 2k by 3 times of L, right? Now for spring 1 will also have mg equals to k into L1. So L1 will be equals to mg over k, and mg is 2kl by 3 times g by k. So mg is 2kl by 3 upon 1 by k. So this k and this k gets cancelled. So you get 2l by 3. Option D is the right answer. Because in spring constant, if you, let us say if this is the first spring and this is the second spring, this is the load. So for spring 1 and spring 2, the load will be mg for both of them. So for here this will be L1 will be mg upon k and L2 will be mg upon 2k because the spring constant is 2k, and the combined I can say the total L1 plus L2 will be equals to mg, or this will be kx. This is the total L1 plus L2 equals to mg. Okay, so this is how you can solve for the series one. Now pause the video for question number 11 and solve. Okay, so density of object 1 is rho liquid or rho water into volume is 0.75, which is submerged inside, into G is equals to the density of the object 1 into volume, which is again 0.75, or sorry, this is 0.75 times of V, and this will be V into G, right, upon density of water times second was 0.5 times of V times G is density of 2 times V into G. This is I'm equating the volume of water displaced equal to the mass of the object. So mass is, sorry, weight of the object. Mass is density into volume and into G. So this will get cancelled out and V will also get cancelled out, and this will also get cancelled out. So you will get 0.75 over 0.5 as rho 1 over rho 2. So that will be equals to 1.5. Okay, option A is the right answer. Now try for question number 12. Pause the video and solve for question number 12. Okay, now two balls are there with different radius r and 2r, are made up of same type of steel that fall through a liquid that exert a viscous drag force on the ball, and we know that drag force depends on 6 pi neta rv. If the liquid is same, neta is same, so it depends on the radius and the terminal velocity. The smaller the ball reaches the terminal speed v, so the smaller ball reaches the terminal speed v, what is the terminal speed of the larger ball? Okay, now what we can do is, if the at the terminal speed the weight is equals to the buoyant force plus drag force, right? So drag force will be equals to weight minus buoyant force. Now weight of the ball, I can say density of steel into volume of steel times G, minus buoyant force will be volume of liquid. Okay, liquid is not given, through a liquid. Okay, and volume is the complete volume of the steel ball times G, right? And the volume is constant, so I will take out 4 by 3 pi r cube times G, density of steel minus density of liquid, is equals to 6 pi neta r. V is the terminal speed, so V will be written as 4 by 3 pi r square, because this r and this r gets cancelled, into G, density of steel minus density of liquid, over 6 pi neta. Now if you look, I am highlighting the terms which are constant, right? So for a given condition, these all are constant. So I can say the speed, the terminal speed is proportional to r square, right? So the terminal speed is proportional to the r square. So the second ball has the double the radius, so I can say k r square. So V dash will be k times 2 r square. So this will give me V dash as k times 4 r square. So k r square is V, so V dash is 4 times of V. So the option is C is the right answer. Okay, I hope you have understood this. If you are not, just rewatch the video again, otherwise just comment below. Okay, now solve the question number 13. Pause the video and solve. Okay, again in this we can say if the terminal speed, constant speed means terminal, so weight is equals to the buoyant force plus drag force. Now they are asking us the drag force, so drag force will be weight minus buoyant force. So weight is 1.2 minus buoyant force. Now buoyant force is what? Density of liquid times volume of the object into g, right? So buoyant force, we can say density of the ball, and weight is equals to density of the ball into volume of the ball into g, right? So weight is 1.2. now this is the density of the ball and this is the density of the liquid, and the relation is given that density of the ball is equals to 1.5 times the density of the liquid. So I can say the density of the ball times, or you can say this will be density of the ball equals to V into G, because it is completely submerged, so volume will be same. So I can say Vg is 1.2 over, so if I use this, so F buoyant force is density of liquid times Vg is 1.2 times divided by density of the ball, which is 1.5 times the density of liquid. So 1.5 times density of liquid times this will be Vg, right? So Vg has been replaced by this term, and density of ball is replaced by 1 times density of liquid. So I can write down density of liquid times 1.2 over 1.5 density of liquid. So this and this gets cancelled. So this is 1.2 minus 1.2 over 1.5. So if you solve this, you will get the answer something around, I have already done the calculation, 0.4 Newton. So the drag force is 0.4 Newton. Option A is the right answer. Okay, so I have tried my level best to collate all the different types of questions related to the different types of forces, the equilibrium problems, and the free body diagram or the force body diagram. So I hope you like this video. Make sure that you share with your friends and the classmate. Well done if you have reached to this level of the video. You have completed the worksheet. Make yourself proud. You did it at the end. Keep learning with me. See you in the next video.